If we start with 2 points indicated by the point here and the point here in an XY plane, we can construct the following. We want to find the distance, the slope, and the midpoint between the 2 points. We construct the triangle you see here. One side is the line segment running from the first point to the second. Another side that I'll call the rise runs parallel to the y-axis. The other side that I call the run will run parallel to the x-axis. Since the x and y-axes are perpendicular, these 2 legs are perpendicular, so we can apply the Pythagorean theorem to find the distance between the 2 points. And if you recall the Pythagorean theorem, which is often written c squared equals a squared plus b squared, c being the hypotenuse, a and b being the 2 legs. Well, I'm going to use leg 1 and leg 2 rather than a and b, and I'm going to just say distance rather than c. So this really says that c is the square root of a squared plus b squared, which follows very simply from the Pythagorean theorem. Now, if I choose to let leg 1 be the one that I've labeled rise and leg 2 the one that I've labeled run, it follows that the distance is the square root of rise squared plus run squared. What else do we know? We know that slope is rise divided by run. So that should be very familiar to you. And midpoint is what? Well, the midpoint is going to turn out to be the point whose coordinates are the midpoint between the 2 x coordinates. So we take the x coordinate of this point and the x coordinate of this point. Now, if we had the x-axis extended out to here, the x points would be here and here. We go midway between those 2, and that's going to be the x coordinate of the midpoint. And if we have a y-axis extended out here, then the y values are here and here. We go to the midpoint of those y values, we get the y value of the midpoint of this segment. Now, we can formulate this very simply. So I'm going to simply add labels to these points. I'm going to say this point is x1, y1, and this point is x2, y2. Then we're going to be able to say what the rise is and what the run is in terms of the coordinates x1, y1, and x2, y2. So we'll be able to replace the rise and the run with expressions involving the coordinates of the 2 points. And having done that, we can do the same thing to get the expression for the slope, and then we can find the average x and y values to get the midpoint x and y values and put that in terms of these coordinates. And I'm going to go ahead and fill those in. Okay, if you think about it, the run from here to here is going to be, and I'm using this arrow here to indicate the order in which I think of these points. This is the first, this is the second. I could as easily have labeled this x1, y1, and this x2, y2, but we would go from the first point to the second in labeling the run and the rise. It really doesn't make any difference which way you go, as long as you go the same way for both the rise and the run. So declare what direction you're going and calculate the run and the rise. The run then is x2 minus x1. Again, if you had the x-axis here, your coordinates would be x1 and x2. If you subtract x1 from x2, you get the run. Okay, and similarly, y2 minus y1 is the rise. Now, replacing rise and run, we get y2 minus y1 squared, x2 minus x1 quantity squared. Again, same thing with the slope, rise divided by run, y2 minus y1 over x2 minus x1. The picture should precede the formulas. You're going to forget the formulas. You'll remember the picture if you know how to sketch it. Okay, the midpoint is fairly obvious. Halfway between x1 and x2 is the average of x1 and x2, and that's what you get if you add x1 and x2 and divide by 2. Similarly, halfway between y1 and y2 would be the average y1 plus y2 divided by 2. So here we have the complete calculation in terms of one simple picture of distance, slope, midpoint, and these are the formulas that are usually given but often given, memorized, and used without really understanding them.